Okay everyone, well here goes. I'm going to try to do this in one take. So if I say something stupid, it's just going to be out there. Anyway, this is an attempt to let you guys, by watching a videotape kind of at your own pace, maybe in the comfort of your own bedroom or just, on the Saturday or Sunday morning before we collect these things, with your cup of hot chocolate and your bowl of cereal and your footy pajamas still on, you can kind of review this and hopefully learn at your own pace and have fun doing it. So I'm going to go through some of the tougher problems that you'll find in your summer work packet, and I'm just going to go through it quick, and then like I said, you can pause it if it's hard and you can rewind it and listen to it again, but I'm just going to go quick and talk fast and get through as many of these as quickly as possible. Alright, so here we go. The very first one is the solving section, and I've chosen the last problem. When you're solving a problem like this, you want to take a look at the signs, pay careful attention to them. Also fractions, easiest thing to do is just multiply by a number that will clear all the fractions. This one only has one fraction, so it's not too bad. We multiply everything by 4. If there had been like a 3/7 or something and some other stuff there, we'd multiply by whatever the lowest common multiple of 4 and 7 is, and that would be 28. I'm going to multiply everything by 4. So if I put my little 4 out there and graphically represent that I'm multiplying everything by 4, it all makes it easier. Now notice I don't multiply both of these by 4 because this is considered one entity, one term. So that becomes 12. The 4's cancel. That becomes minus 3 times 2x plus 6. And then the 4 times that becomes minus 12 over there. If I add or if I subtract 12 from both sides, I get minus 3, and 2x plus 6 equals negative 24. Notice these don't cancel out, don't do anything silly like that. I'm subtracting 12 from both sides. And then I multiply both sides by negative 1/3, or I just divide both sides by negative 3, and then I get 2x plus 6 equals a positive 8. Okay, I'm just going to move this up here to save room. And then I subtract 6 from both sides. We can do that in our head. We get 2x equals 2, and so x equals 1, and I get my one solution there. Okay? Now this is part 2. Again, I think I'm doing the last problem there. So again, this is problem E from section 2. Again, I survey it just to pay attention to the signs. I don't have any fractions. I'm going to divide both sides by a negative 5. When I divide by a negative 5 and divide by a negative 5, then these cancel, and this cancels, and I get a negative 3, and I get minus 4 minus x. But now the rule is you have to switch that sign. So when you divide or multiply by negative, you switch the sign, and then you get 12 minus 3x. Okay? If you think about why that is, it's simply because if I had done the math, if I had subtracted this from this side to move it over here, and then subtracted this to move it over there, I would have changed the signs, but that would not have switched, but their relative way that larger or greater than sign is aiming would have switched when it moved over. So if you think about it, it does make sense that we switch the sign when we divide or multiply by a negative. Then I go to solve this, and I divide everything by a negative 3, or I distribute in, I guess I'll do that first, and I get positive 12 plus 3x because I bring in the minus sign to that, and then I've got is less than 12 minus 3x. Now I can cancel the 12s from both sides, okay? But be careful here, these do not cancel. I'm going to add 3x to both sides, and I get 6x is less than 0. I can now divide both sides by 6, and I simply get x is less than 0. And that's my solution. If I go to graph that, I'll just sneak it in up here. There's my 0. And if x is less than 0, I circle that. I do not fill it in. And then less than is obviously going towards the left. All right, there's 2 problems, and I'll reset. Okay, I'm back with 3 and 4. One thought that I had after looking at 1 and 2 is that there are multiple correct ways to solve these problems. So don't think that my way is the only way. Sometimes you can distribute things first and then divide later. I tended to divide first and then distributed things that didn't work out when I divided. So a little bit up to you how you want to do it. Okay, so this is an absolute value problem. So in an absolute value problem, you want to isolate the absolute value first. So to do that, I divide both sides by -2. So if I divide by -2 and divide by -2, I get absolute value of 1 minus 5x is then equal to a positive 9. Now at this stage, this little part in here could be a positive 9 or a negative 9. So I'm just going to branch this into those two possibilities and do 1 minus 5x equals that positive 9. The absolute value would make it 9, but if that was a negative 9, then it would be 1 minus 5x equals negative 9, and then I just solve both of these. If I take away 1 from both sides, I get 8, and I divide by a -5, so I'd get negative 5x equals 8, and then x is going to be equal to a negative 8/5. All right, I hope I'm not skipping too much, but that's one solution. When I divide both sides by a -5, that becomes x equals a negative 8/5. Do the same thing to this side. You can pause and try it on your own. It's not rocket science. I hope you get it first time. I subtract 1 from both sides, and this goes to -10, so negative 5x equals negative 10, and then x is going to be equal to a positive 2. So those are your two solutions for that one. Okay, now the second one I've got is not one of the ones in 4 because there are only two problems, and I want you to really work on both of those. But I'll do this one two different ways. It says by any method you choose. You could do it by graphing. There are other methods, but the standard ones are by substitution or by combination method, where you combine these vertically and you line up the x's and the y's to get them to cancel. That's actually kind of the sort of the niftiest, most standard way of doing it. So I'm going to do that way first. I want somehow the x's to cancel out. So I need this to be a -2. So when I add it to the positive 2x, it'll cancel. So if I multiply everything by -2, this becomes -2x, this becomes -4y, and this becomes, when I multiply by -2, a positive 10. I'm just trying to save space in the whiteboard. I don't recommend you doing it by erasing. I just write it down a second time. But then I just draw a line and I add vertically, and poof, these are gone. They cancel each other out. This becomes -7y equals positive 16, and so then y is equal to -7/16. Okay? Then I would take this answer, it's called back substitution, and I'd plug it in up there and I'd work it out. It's going to be a little bit messy, but I'll do 2x minus 3 times my solution, -7/16, and then that's going to be equal to positive 6. Okay? Well, 2x then is going to be plus 21/16 equals 6. Okay, now I'm going to subtract this from both sides. Well, that's going to be 1 and 5/16. If I take away 1 away from 6, I get 5. And if I take 5/16 away from 4 and 16/16, I get 4 and 11/16. So it becomes 2x equals 4 and 11/16. It's not easy, but that's the way it is. Then if I divide everything by 2, I guess I can convert this. 4 times 16 is going to be 64, plus 11 is 75. 75/16 when I multiply both sides by 2, the 2 are by 1/2. X then will be equal to 75/32, or it'll be what? 2 and 11/32. Which makes sense, because I could have taken the 4 and cut it in half and had 2, and taken 11/16 and cut that in half and made it 11/32. So that's the two solutions. This is doing the combination method.